In Chapter 8, let's look at number 51. Using the methods you have learned, find the volume of the region bounded by square root of x, y equals 0, and x equals 4. The only thing that could be bound there is this region here. Revolved about the lines below. And looking at what we did in 49, we've got a rough sketch of our area. So if we want to revolve it around the x-axis, what will that look like? Here is the x-axis. So if we want to revolve it, what shape am I going to have? Some kind of a, almost a cone-ish. Got a solid going around here. Now, the first thing I would want you to write down is we are going to use discs. There's no holes, so we've got it. Then we need to decide where is our generic rectangle and what does it look like? There it is. So what is our integral of pi r squared? So what is our r? What's our radius? Our radius is going to be our y's, and our y equals square root of x. So there's our radius. Now, if we're talking about x's, we're going from 0 to 4. So the integral from 0 to 4 of pi r squared. dx represents the height of each one of our discs that we're adding up. Around the y-axis. So let's resketch, get our rough sketch, because now we want to go this way. Still our 0 to 4 on the x and our 0 to 2 on our y. But now if we revolve around the y-axis, this guy over here, this area, so there's the top. I'm going to do this middle just because for me it's a little easier to see a washer right there. So if I say washer, I want to write pi r squared minus pi r squared. And now I just got to decide what my r's are. When you've got this nice solid outside wall for your big R has got to be 4. Now, my general rectangle is going to be right here. So if I write it vertically, it is my x values. My x's are my, so I want to do the y equals square root of x. So I need to do x equals y squared. But this outside radius is nice and easy. Now if we're doing y's, we're going from 0 to 2. My big radius is the 4. And my inner radius, let's take a look. Right here, I'm subtracting this guy, subtracting this guy, subtracting this guy. So what are those values? Well, here y is 0. Here I want to subtract the whole thing of 4. So that's just going to be my y squared squared. Good to go. Very similar problem here. In C, if we want to go around, x equals negative 2. So here's our sketch. Where is x equals negative 2? So if I reflect around this, I've got to go another before I get that reflection. There we go. So what does that look like? Let's take a look. Nice big top there. Now I'm going to have an actual hole here in the bottom, And then I always like to draw the one in the middle to show our actual washer. So right here, let's see if we can get this drawn in nice. Here's my big radius of my washer. My big radius is unchanging, but it's not 4. This is 4, this is 2, so my big radius is 6 this time. And my inner radius isn't just my y squared, it's going to be my y squared plus 2. And that should be good. And it's got to look something like that, I believe. Y equals 6, y equals 5. Good. So we've got this solid here. There we go, taking some shape. Now, again, very solid outside with our disk inside, our washer. Pi r squared minus pi r squared. So my outside radius is again very solid. Here it is. So it is always going to be, well, 5. It's always going to have a height of 5. We're talking about x's, so we're going from 0 to 4. 5 squared. Now let's look at this inside. This is 5. This is what we want to subtract off. What is this right here? That is the square root of x. So I know it's not that easy to picture, but we want to do 5 minus square root of x will give me this right here that I want to subtract off. That's where that comes from, 5 minus square root of x. That gets me, and let's look at it like right here. This is 5. This is the square root of x. So if I do 5 minus the square root of x, I'm left with that right there that I want, squared dx. Probably the best I can do. Just keep practicing these problems.